Welcome to installment number 3 on electric current. We're trying to deal in this one with the purpose of the battery and the role it plays within the electric circuit. Now, you can think of it in essentially 3 ways. At first, it's the supply of energy. Now, since a battery uses chemicals to create that energy, eventually it's going to use up its chemical ability and it'll go dead and won't be able to supply any more energy to the circuit. Second, the energy supplied has to be used to do the work that gets the electrons, the charge, from the positive terminal where they'd like to stay to the negative terminal of the battery. So it's analogous to lifting something in a gravitational field. And then third, in moving the charge, you create a difference in the ability of the charge to do work, so you create a potential difference between the two terminals. So for a battery to work, there must be a difference between the potential of one terminal and the potential of the other terminal. When the battery goes dead, there is no difference between the two terminals. They both have the same potential, and therefore you can't make the charge move. Again, that would be similar to having an object on a table. You wouldn't be able to use its potential energy to move it on the table, because then you would just be moving from side to side. You'd have to lift it or make it fall to use the potential to do something for you. Okay, now the potential difference, again, symbolized by delta V. It is measured in volts. It's often referred to as the voltage, which is not a descriptive term, but just based on the person's name, Alessandro Volta. It is the difference, so therefore you would be subtracting. And it's always going to be the high minus the low, because the charge is always going to move from higher points of potential to lower points of potential. Now, we define 1 volt of potential as the ability to move 1 joule, to expend 1 joule of energy to move 1 charge, which would be the unit of 1 coulomb. So if you're trying to figure out how much of each of those you need, essentially it would work out like this. It's 3 elements, so I can just break it into a little triangle here. Your potential difference V, or your potential V, would be here. Your energy in joules would be up here, and then your charge Q in coulombs would be down here. Now, if I'm trying to figure out how much voltage I need, I would just need to take how much energy I had to expend and divide it by the amount of charge that I needed to move. If I was going to look for the amount of charge that I could move, I'd need to know how much energy I had to expend and then how much difference I want to give it. Now, if you think about it, in a higher voltage of battery with a higher potential difference between its two terminals, you're going to have to do more work to move the charge to that higher potential. Similarly to how you would have to do more work to lift a rock to a higher height in a gravitational field. So it works very similarly to the way that gravity works. Okay, so we're just going to go through those 5 that are here and figure them out. So I want to know how many joules of energy it would take to move 1 coulomb of charge from a no potential to 1.5 volts of potential. So that's the E, the energy I'm looking for. So I'm just going to multiply the potential that I need, 1.5 volts, times the charge that I'm moving, 1, and so that's going to be 1.5 joules of energy. Again, if I need the energy, I'm just going to multiply the potential that I need to get by the charge that I'm moving. 12 times 2 is 24. Now, notice how much larger 24 joules is than 1.5 joules. We have a much larger battery, therefore we have a much larger potential and a potential difference between its two terminals. And we're also moving twice as much charge. So to move more charge across a larger difference in potential, we're going to need to do more work. I mean, that should just be seem natural. Alright, now this time we're looking for the coulombs of charge, so I'm really actually looking for the Q. So I'm going to take the energy, 18 joules, and we're going to divide that by the potential of the battery, which is 12 volts. 18 divided by 12, we're at 1.5 coulombs. Now we could have figured that out from the previous one as well if you think about it. 24 divided by 2 gave us 12. If I'm only using 18 joules of energy, then I must be using about 1.5 as much charge when I'm moving it around. And letter D, it takes 12 joules, that's the energy, that's E, to move 2 coulombs of charge, that's Q, from the plus to the minus terminal of a battery. So we're trying to figure out the potential difference of that particular battery. We're going to take the joules that we used, 12, and we're going to divide it by the charge we moved, 2, and that means we must have a 6-volt battery. So again, if you go back to B, we're moving the same amount of charge, but we're only using half as much work. Since we're only using half as much work, we're only going to get half as much potential difference between the terminals. Now, that's, again, similar to taking the same rock, and in the first case, we lifted to a height of 12 meters, and the second case, we only lifted to a height of 6 meters. Right? It's the same mass, but we do less work to lift it to a lower height. Finally, this one actually has 2 pieces missing, so any combination where the 2 will come out to the third one will work. We're talking about a 12-volt battery, so we're talking about 12 volts here. So any combination where you divide the energy by the charge and you get 2 would work. So it could be 6 divided by 3. It could be 12 divided by 6. It could be 18 divided by 9. Any combination, and they don't have to be whole digits or integers or anything else. It could be decimal values, just as long as the ratio of the charge that we move to the energy necessary to move the charge stays the same. So you can have a AA battery, which is pretty small and has a potential difference of 1.5 volts, and then you can have a D cell battery, which when you look at it is much larger, but it still has a potential difference of 1.5 volts. And the reason you would use one battery over the other is simply the number of joules that it could move. A larger, more battery filled with more chemicals can move more coulombs over a period of time. So there are a lot of different elements that go into moving charge around a circuit. The potential difference and the potential at any point is just one of those. Okay, we'll look at how to track that through a basic circuit in the potential diagram next, and then that'll wrap up our initial discussion here of potential and potential difference.